Hi guys, welcome to our channel. So in today's session, we'll be doing multivariate analysis. In the previous two videos, we had explored bivariate analysis. So in today's video, we'll be discussing some of the more additional functionalities which are present inside Python when it comes to using matplotlib and seaborn modules. So let's get started. So I've already written a piece of the code so that we not waste much time in writing the code. We have taken a data set which is called as Titanic, which we have already worked in the last video as well. So what we'll do here is the survive column initially had 0 and 1, as you can see here. I'll map it to non-survive and survive. So it becomes easier for us to get a hang of what is actually happening in the data set, what insights we can draw. It'll be easier for us to relate to it. But for modeling purpose, of course, all these strings needs to be converted to a number. Now, the survive column, I'm just targeting it as, rename it as Y, because that is my target variable. And that is what I'm going to evaluate with respect to all other variables which are there. Okay. So I'll drop the passenger ID, which is not required at all. So this is my data frame which I have. Now, if I want to do multivariate analysis, whenever I do multivariate analysis, there is a easy way of directly doing it, which is called as facet grid. Now, facet grid is a function from seaborn, sns.facetgrid. Now, what does it do? So sns.facetgrid, basically, it will allow you to create grids based on certain conditions. Okay, now let's see what are those conditions and how does it create the grid. Okay, so sns.facetgrid, if I simply do simple facet grid of df, it will just give you one particular grid, x and y axis, because we have not told facet grid what to plot, right? But if I include column is equal to p class, so p class is a column here, as you can see here. P class is a particular column here. If I simply do sns.facetgrid of df, comma, column is equal to, this is call, this is the argument inside facet grid, is equal to p class. Let's see what it does. You can see here it has given me three different grids, or one grid of three different figures. It has given me three different figures, right? Why? Because p class has got three categories: 1, 2, and 3. So there are three types of passenger class: first class, second class, and third class. We already know that from the data set. Now, if there is one more argument which is called as row, okay, so if I make row is equal to y, let's say row is equal to y, what do we get here? You can see there are two rows getting created. So what does it mean? It simply means row y. What was y? So what does it mean? We know that y is nothing but my target variable survived, and it has got two conditions: not survived and survived, right? Not survived and survived. Now, if not survived and survived is there, which means that there are two categories, and that's why it has created two rows. So basically, row and column in facet grid helps us create a grid, a matrix of figures. How many rows and columns will be created? That is dependent on the number of labels present inside those particular columns. So what I'm trying to say here is sns.facetgrid of, say, row, comma, columns. Okay, so this row, if I equate it to that y column, right, and this column I equate it to p class. So p class has got three categories. Y has got two categories because it is survived or not survived, right? 0 and 1, whatever it is. Now survived and not survived. Now, if I want to create a matrix of this, I already mentioned row should be this. So there'll be 2. So this is size 2 and this is size 3. So 2 rows and 3 columns. 2 rows and 3 columns. And this is my p class 2, p class 3, p class 1. And this will be survived and not survived. So what is it trying to do? It is segregating the data, right? It is basically dividing survived and not survived against each of the p classes. Now, in these grids, I can plot anything. I can do a scatter plot between two other continuous variables. I can do a simple univariate analysis of bar plot. I can do a count plot, whatever it is, whatever comes to your, whatever you can want to analyze, you can do it. So each of these individual grids now will contain a figure of two variables. So it's a multivariate analysis because you have already done a segregation based on P class and survive, not survive. And then again, you can, do a scatter plot between two additional columns or a count plot. So you can check up to more than two variables at a time. Right. So all this will give me strong relationships, which I can probably infer from the data. The more complex the analysis, probably the chance of me deriving insights increases. And it is not something very complex. We are simply segregating the data further into a minute level. That is what we are trying to do here. That is what facet grid does. So that is exactly what I'm going to show you now. So now, if I saw that if I specify column, it is P class. If I specify row as Y, it will give me two rows. Now, what is very good here of facet grid is that it's very flexible. It is not necessary that you have to put both row and column. If you simply put column is equal to P class, it will mean that it will automatically create one row of all the P classes. If I simply do row is equal to Y, it will simply create one column of these two rows. Right. So if I do not mention the other parameter, it will automatically take it as one because there is no other column which you have not, because you have not specified any column to the particular row or column entity. Correct. So let's say now if I do SNS dot facet grid, okay, df comma say row is equal to Y and column is equal to P. Now if I do this facet, this G should be capital. Be very careful with the function names. So now you can see it's a 2x3 matrix. If I include both of them, it becomes a 2x3 matrix. Now, embarked, I guess, also has three categories. Okay, let's say male and female, sex, right? So if I do between sex and survived, how many matrices will be done? So if I do okay, let me make this as sex. So sex has got two categories, male and female. Y has got survived and not survived. So basically what it'll do, it will again create a 2x2 matrix. Very simple, right? Now let's get back to the basics and try to, okay. So now let's get to the chase. Now, once I initiate the facet grid, next what I have to do is I have to map this particular grid which I have to a kind of a plot which you want to use in each of these grids. So basically you have now, it's your turn to tell the machine, okay, key within these grids or in each of these grids, what plot do I want to do between what variables? Okay, whatever plot you want to do, it will be segregated across the rows and columns. Okay, but you have to tell the machine what kind of plot you want to do here. Suppose I want to plot the age column. Now age is continuous, so I have to use a distribution plot, right? So that is what I have done here. G dot map. So you have to save this facet grid in a variable and then do G dot map SNS dot plot age, comma is equal to false I've given because I just want to plot the distribution. Okay, so if I simply do this, okay, let's see what it gives me. Right, and if I do not want these histograms to be seen, if it's looking a bit dull, then you can just remove the histogram. Okay, all right, now if you look at this row wise is nothing but my not survive and survive, and this is P class 1, P class 2, P class 3. So we can compare, within the same P class, you can compare not survive against survive, and also you can compare within that same class of survival or survival against all the P classes. Now, if you look at this row-wise analysis here for only for not survived across all P classes with the age, right? So this is 25, this is 50. So around the age 50, right, 45 to 50, around that age, people has the highest probability of dying, right? Because their probability is highest, correct? Whereas we move to P class 2, second class, people around the age of 25 actually has the higher probability of dying, because probably what would have happened is P class 1 would have had aged people along with some other youngsters, and we were asked to evacuate first. Of course, the survivability ratio will be, non-survivability ratio will be low here compared to P class or P class 3. But if you look at the age criteria again, youngsters seems to have more than youngsters. So youngsters seems to have survived more here in P class 1, right? Whereas youngsters in this category, P class 2, have died. Even in P class 3, youngsters seems to have died more. Youngsters that to belonging to second and third class was probably a dangerous combination to survive, right? Whereas here, if you look at this, youngsters have survived more than the aged people in P class 1. Now, if you look at the survival ratio, the opposite one, right? If you look at the survival ratio, see, 25 to 50, between 25 to 50, around 25, the survivability is more. Makes sense, obviously. And then here also, right, the survivability ratio, correct, between especially more than 25, right, has more chance of survival. Same goes for almost, for the P class 3 as well. So overall, if you look at the age criteria, right, in P class 1, it was more of youngsters who had, survived. In the other, classes, it was the youngsters again who faced problems in surviving, especially in P class 2 and P class 3. And P class 2 and P class 3 seems to have the same kind of distribution, for both non-survived and survived, with respect to the P class 1. So when one moves from P class 1 to P class 2 and P class 3, the trend seems to have changed. The trend seems to change. So this particular criteria, which is age, is actually indeed capturing information. And combined with P class and survive, not survive, it's actually giving us a lot of information. Right? That is how we can actually analyze. Distribution plots are a bit, complex to understand, but if you get into a crux of it, it'll take some time, but you can definitely derive some really wonderful insights. Now what I'll do is, now age was a continuous column. I'll do the same segregation, P class versus survived, not survived, but now I'll be understanding the sex ratio, which is male and female. And male and female is a categorical column. So I'll be using count plot, right? So that's why I'm doing count plot. Everything else is same, just that I'm replacing this distribution plot with count plot because my column here is sex. There's some warning coming on. You don't need to bother about it. You can import warnings and filter it out. So now if you look at this again, not survived and survived. So if you look at not survived and survived, so this is your female and this is your male, right? So as soon as you move from, class 1 to class 3, right, or P class to P class 3, especially in P class 3, the females dying and males dying, for both of them, the non-survivability or the survivability ratio, survivability probability decreases significantly, or the non-survivability probability, non-survival probability basically increases, right? There's a less chance of people surviving as one moves from, especially from class 2 to class 3. And you can see a significant increase in both females and males. But interesting thing is here is that between P class 1 and P class 2, there is not much significant change in the non-survivability ratio, right, as opposed to the age criteria which we saw. Whereas in survival, again, female tends to have the higher weightage than male, right? Correct. So everywhere your female survivability is more. But if you look at the survivability with respect to the non-survivability, your P class 1, probably females tend to have survived more than males. Now I can also understand this particular analysis in a different way. Okay. Now if you look at the count of females, right, or count of males in both all these each of these sections, in you will find will notice one change, and the change is very simple. In P class one, right, the female non-survivability or the female survivability, if you look at this, right, the count is almost the same, whereas for male the survivability chance is higher than females in P class one. Although the count is less than female, but if you consider the ratio of survivability to non-survivability, right, males have a higher chance of surviving in P class one, right? Same goes for P class two. The survivability ratio of males was higher in P class three as well, right? However, in P class two, the survivability of females was probably slightly higher than males. Right. To do this, you have to, find the relative survivability divided by non-survivability. That is how we have to find out relative scoring. So all you have to do, you have to look at the difference in the height of the bars. So here you can definitely see that non-survivability is much higher than survivability for males. Number of count of women who have died is much higher. Whereas males, you don't see a very significant growth in dying in the P class tree as compared to the females, right? Okay. So here also you can see here, it's almost the same survival to non-survivability in P class one. So there's almost like a 50-50 chance of survival. But for males, it's higher because you can see this graph, this bar height is very low compared to this bar height, which is almost 4 times than that. So when you are probably in P class one, you have 4 times more chance of survival than the females. And that is how you basically try to analyze data using facet grade. So facet grade basically allows you to understand, interpret, insights from data in a granular level, because it segregates the data, right? It bifurcates the data into different subsections, and that is where it starts revealing all these patterns. You can do the same thing using group by also, right? Basically what we are doing here, we're doing group by P class and group by also non-survive and survive. It's pivoting. That's it. Now, if I want to, do a bar plot, correct? A bar plot of sex versus age, correct? So what will you give me? When you do a bar plot of sex versus age, with respect to different sex, male and female, it will give me the median or the mean age. By default, it gives you the mean age. If I want to make the median, you have to use a estimator, right? Which we had done, I think the first session or second session. So what this will alone do is basically it will give you the mean age. The bar height will represent the mean age with respect to male and female. But again, I'm using facet grade on top of it, so it will, bifurcate into different pre-classes and non-survived and survived classes. Right? So now you can see here how the age varies with respect to male and female. Correct? So this is female and this is male. Okay, non-survived, survived, 1, 2, 3, female and male. So you can see here that as soon as you move from non-survivability to survivability, right? Correct. The age of male increases. So people or males who had slightly age between 30 and 40, correct, had a higher survivability ratio than this. Whereas for female, the age seemed to have decreased when it came to survivability, right? So you can see a reversal of trend, female to male and female to, so it's almost the same. But here there's a significant difference in the age. Older females seem to die more, right? In P class 2 also, it's again a reverse. This trend which you see here, it's repeating in the survivability for P class 2, reversed. correct? So in each of these graphs, you can see there is a, change in the pattern. If there are changes in the pattern, changes in the data set, or there are patterns in the data set which is deviating, it is good for us, because that is that means that the data is giving us information. So for modeling purpose, it will really help the machine to draw patterns and understand those patterns and start predicting or make predictions, right? Okay, but this is how you basically try to plot. So today's exercise is more than drawing insights. It's about the visualization techniques which you use. So please focus on these techniques. Yes, doing face and grid does not necessarily mean every time you have to draw insights from data. Sometimes after doing face and grid, you will see that there's not much to draw, but it's fine. But understand, you try it, how will you know, right? That is what it basically means. And this line you see here is basically represents some kind of deviation. So although here the age is, the mean age lies between 20 and 30, but the deviation is pretty large. Right? Probably less number of data points from male in this particular section, or the survivability, the age probably it goes down to as low as probably 10 years old, or it may be as high as 50 years old. So people who have not survived, although the mean is showing between 20 and 30, but there are data points where it can be as low as 10 or as high as 50. Because ultimately, when you calculate average, extreme values both on both sides will again, give you the same mean value, right? But this bar, the line which is there, is trying to tell you that although the mean is between 20 and 30, there are extreme data points in this particular bar, or in this particular subset of data. Now, this also gives you an idea of how the distribution of age is when it comes to P class 1. So people of varied age, especially the male section, has traveled in P class 1. The distribution, the range is pretty broad with respect to the females. Same thing, instead of P class, I'm choosing embarked. Embarked is the column which tells you where the people have boarded the ship. There are three categories, right? CS and Q, Southampton, some kind of other, districts or cities, whatever it is, where they have boarded the ship. So basically here I'm trying to see, how, the survivability ratio of male and female as they embarked on the journey from different, places, right? So here you can see S. So S definitely seems to have been the city with the most number of people coming from that particular place, because the count in both the cases seems to be high with respect to the other count. So S was the mode, if you remember, embarked. And you can see here the non-survivability ratio. If you look at the non-survivability or non-survival probability, right, for females, it's pretty significant number of females seem to have died with respect to the males. Whereas when it comes to survivability, there is not much difference between male and female. But when it comes to dying, the female count is pretty high with respect to the other places. The other places, there is not much difference. You can see here, same trend almost, right? It's almost the same trend. C, S seems to be the most prominent place where people might have boarded. It's probably the major port, probably Southampton. That is where they have boarded. Maximum number of people have boarded. Next, I believe it is C, because C seems to have more count than Q. And finally, we have Queens, I guess, right? But the ratio, if you look at it, it's not much difference. But here, the ratio is different, obviously, because more number of people have probably embarked from Southampton. Now, what I have done here is I have now if you remember in the previous diagram here, I think I've already done sex and age. Okay, so this is not, so this sex and age was with respect to P class. Now this sex and age will be with respect to embarked. This is how it goes. Yeah, so if you look at this from Southampton, people who embarked, look at the age, right? So the mean age, I would say, is around 30 for females, and this is for 25th, people who did not die. right? Okay. Whereas for this, so there is not much difference in the age criteria in Southampton, people who died and people who did not die. It's as if, the same kind of age, right? People who died and not died. But if you look at C and Q, there seems to be a difference, right? There seems to be a difference. This is above 30. This is somewhat below 30, right? And the age of people dying to not dying also seems to have reversed, non-survived and survived. So C and Q is probably capturing more information than S in this particular criteria, but doesn't mean that S is a insignificant uh, category, because in the previous category we saw that S had a totally different pattern, right? So when we try to segregate data to the basic level and general level, we can draw out many insights, more insights from the. Now let us try to understand how many P-class passengers were there with respect to all these embarked positions. How will you do it? Very simple. I need a group bar plot for that, right? Of embarked in P-class. So what I'll do, SNS dot count plot, okay? And I'll do, let's say, df x is equal to, or I can simply do df of embarked. If I simply do this, I'll get 3 bar diagrams of C, S, C, and Q. And if I simply do hue is equal to P class. Oh, could not debit P class. So I think it's P capital. Okay, let me just make it about to this. Data is equal to D. So now if you look at this, right? So earlier diagram, what was it? It was very simple. It was x equal to embarked and this. Now this blue is further, this particular S gets further subdivided into different P classes and its count, right? So if you look at S, the P class for Southampton was maximum. Whereas for C, the number of passengers who were in the first class probably was higher, with respect to S and Q. See, guys, so many insights you can draw. This pattern which you see, that 1, 2, and 3 number of passengers in third class was more, followed by number of passengers in second class and then first class. This trend is the same for S and Q. Whereas for C, it is showing somewhat different, because number of passengers in first class seems to be higher with respect to the other two in proportion, okay, in proportion. But the count is still low, right? The count is still low. The count is still low than the for number of first class passengers in Southampton. But within C, this is the highest as opposed to the other two cities or places, which means that within C, if you look at the survivability ratio will be more, because people in the P class, people in the first class were more. So the survivability ratio probably would be higher within C. Okay, that is what it basically means. Now, if I want to check the embarked with respect to male and female, right? So hue is equal to, let's say, sex. We can see here, males in this scenario, in Southampton, the male-female ratio seems to have been significant difference. A lot of males were there with respect to females, whereas in C and Q, there was not much difference. Proportionately, there was not much difference. Or the number of females were more here because number of people who, boarded the ship were more in S, of course. But if you look at the proportion of male-female difference, it was the highest in S. Okay, guys, so that is all for today. I hope you enjoyed today's session. We used facet grid extensively to help understand how we can segregate data based on categorical variables, different categorical variables, and evaluate other variables with respect to those variables, right? Evaluate other continuous or categorical variable with respect to those segregations. So basically, we are deep diving into data using different categories and labels to understand changes in pattern when one moves from one label to the other label. So basically, it's telling you that all these labels which you see, categories which you see, they are adding value to your data set. They're capturing patterns, which is good because your machine needs to finally learn from this data, right? When we go to machine learning modeling. All right, guys. If you have liked today's video, please like, share, and subscribe. See you in the next video.